Here we go, starting the Copper Lab Part A. Safety glasses on. We are ready to roll. Milliliters of the 6 molar nitric acid I will be using. Then we are going to take a look here at the balance. When we get to the balance, we need to measure the mass of the Fleeker we are working with. So make sure you record that number, 88.17. Then I am going to do what's called zeroing or tearing the balance so that we are just taking the mass of the copper that I am adding in. We also need the mass of that at 1.43 grams. Next up, we need to make the 6 molar sodium hydroxide necessary for Part B. In order to do that, we will take a pre-measured mass of sodium hydroxide solid. It's in pellet form. Add it to this Fleeker and dissolve it in water. So again, this is the sodium hydroxide that we are going to react with our product from Part A. Once stirred, we make sure that's all dissolved and we'll be ready for Part B. All right, we are ready to start Part B. Part B begins by using pH paper, which are these little strips here, to test the pH level of our product here. So I'm going to take tweezers, dip this in, and then we're going to use the color chart here, and you will see that your pH is somewhere in between 1 and 2 there. In addition, it is also going to ask you to find the pH of the sodium hydroxide that you will be using. So we're going to dip this in as well, and you will see based on the color chart here, that is on the opposite end of the spectrum, somewhere around a pH 12. From there, we are asked to make a water bath. So in a water bath, or an ice bath, you're going to put a bunch of ice in the bottom of this. And then I'm going to add a little bit of water to this. And this is meant to keep your product cool as you are adding the sodium hydroxide to it. So this is going to create a considerable amount of heat, so I'm going to go ahead and dump the rest of the ice in there. And then I'm going to place my Fleeker on the top here, making sure that it does not fall into the solution. Okay, we're going to turn this around a little bit so you can see. And then I'm going to add, as it says, 5 milliliter portions of sodium hydroxide while stirring. And the ice bath, again, is to keep everything cool. So hopefully you can see when I do that, you get this blue, chunky looking precipitate. You can kind of see it on the stirring rod there. I'm gonna make sure I try to keep everything in there. Next addition gets us a little more. And I'm gonna stir there. Very chunky, a little bit lighter blue precipitate. Third addition gets us even more. And then finally, I'm going to add in the rest of that and stir. And then this next part is very important. You will see in your procedure that the product that we have just made needs to be basic. So I'm going to take my stirring rod and I'm going to rinse off with some deionized water any extra precipitate I have on this. That water is not affecting or causing any sort of reaction there. You'll notice nothing changed when I did that. And then I'm going to use a pH strip again, and I'm going to make sure that this is at a basic pH. All right, and clearly we're back up probably in the 11 range, so I can move on to part C from there. Okay, and that's going to involve me taking this out of that solution. So you can see the chunky light blue precipitate there. And we are on to part C. In part C, you take 80 to 100 milliliters deionized water, add it on top of your part B product, and then we are going to light this Bunsen burner and see as this progresses. If you zoom in, you're going to see little black flecks starting to form. That means I am getting close to my finished product for part C, but I need to keep stirring and heating. Here's your product. I am once again going to rinse any extra particles off with the wash bottle. In the last part of C, we are going to do what is called decanting the precipitate and then washing the precipitate. Decanting means that I am going to separate the solution level from the solid precipitate that's there. So I am going to carefully pour into this beaker. I am going to pour out the liquid level at the top of this. Okay, and I'm going to be careful to not pour out any of those black solid particles. And if you look very closely, you can see that I'm losing a few of those. That's a little unavoidable, and that is important. But I'm going to do my best to get all of the, again, the aqueous solution off the top of my precipitate. And when I start pouring out lots of black particles, that's when I'm going to stop. So I'm going to be very careful there. Oh, and now I got quite a few out of there. Okay, so I'm going to stop there and move on to the washing process. And during the washing process, I'm going to take 80 to 100 milliliters, again, of the extra deionized water that I have. And I'm going to make sure that I rinse down all these particles that are on the edge, just so they fall into there. And I'm going to stir a little bit. And then I need to, again, let that settle, so that I have two separate layers. Once the precipitate has settled at the bottom again and you have two distinct layers with no black chunks, you would decant again and then wash 2 more times. Getting closer to the end here, we are now on part D, where we will take 2 molar hydrochloric acid, pour it on top of our part C product, and stir like crazy. Hold on to this. You can stir with a stirring rod. You can also, at some points, it's easier just to lightly swirl. And we should eventually see a color change. Again, the procedure packet will help you figure out what it is you are supposed to be seeing and what is supposed to happen. So I am seeing a slight color change right now as it sits. You're going to see that progress. And I will do this so that noise doesn't occur. There's some black precipitate left in there, so I am going to make sure that that all dissolves. I'm going to add a little bit more hydrochloric acid so that we have again dissolved all of the precipitate in there. Clanky noise again. Part E starts with you taking 75 centimeters of aluminum wire. So I'm going to unwind this, measure that out, and cut it off. And then I'm going to take the wire and form it into an L shape here. So I'm going to fold it once, fold it twice again, make it into an L with the little handle here so I can control it later. I'm going to slide this. I need to make my L a little shorter. I'm going to slide this into the solution, and I am going to let the reaction begin. It will take a couple of minutes again, but you should see the bubbles forming there. And then notice there is a discoloration of sorts on the aluminum wire. So I pull it out. This is what that looks like. I'm going to put it in here and shake it a couple times, and you're going to see those rust-colored flakes falling off on the bottom there. And lots of bubbles still being produced. Give it one more good shake. And then come back with your finished product for part E. Part F starts with removing the aluminum and putting it in the garbage can. And then you will be decanting again. So pouring off the aqueous clear layer that's a little tinted with the orangish red color, which is important in terms of error here. So think about why. I'm going to pour off as much as I can. Now ready to wash the precipitate. I have my hot water ready to go, so I'm going to turn off the Bunsen burner. All right, the last step here, I've added the hot water. I am going to decant again, so I'm removing the aqueous layer from the solid at the bottom of the fleeker, being careful not to lose any particles, which at this case, or at this point, is very difficult because there is some of that reddish orange tint in the solution. And we can't avoid that. So again, pouring off as much as I can without losing large solid particles. I will probably have a little bit of an aqueous layer left on the top here. Oh, big particles, so I'm going to stop there. And then we would repeat that process 2 more times to wash the precipitate with the hot water.